Transformation of graphs. Okay, so to transfer any given curve or any given graph, you need to know some of the rules. Like if this is my basic curve, suppose y equals to x squared, this I have this quadratic equation, and for example I need to transfer this graph into something else. So the shifting of the curves can be horizontal or vertical. For example, if we need to shift the curve vertically upward or downward, it means you are actually changing the y coordinates. Or sometimes you might need to shift the curve horizontally. Suppose you need to shift the curve 2 units or 3 units rightward, or you need to move the curve leftward. In that case, it's a transformation of the x coordinates. So for any vertical movement, it's related to the y coordinate, or any horizontal movement refers to a change in the x coordinates, right? So there can be possible transformations. So these are some of them we will look into today. So for example, the first two, f of x plus 2, f of x minus 2. It means f of x basically represents y, right? So f of x plus 2 means you are actually adding 2 with the y coordinates. It means the curve will move 2 units vertically upward. So let me just show this concept with an example math. For this quadratic equation, y equals to x squared, if we need to sketch f of x plus 2, it means f of x basically means y coordinate, right? So if y, so y plus 2, it means all the y coordinates, you need to add 2 with all the y coordinates. So this 0 point will move to a higher level, right? This will be shifted at 2. The point which was originally at 2 will be shifted to 4. The point which was originally at 4 will be shifted to 6, right? So in that case, each and every single point will just move 2 units vertically upward. So if these are my new points, I can just join them up to get the new look, the curve for f of x plus 2. So the cutting point is shifted from 0 to 2. So this is the sketch of f of x plus 2. The blue one was the original one, f of x, which was just a quadratic equation, right? Y equals to x squared. For the next one, f of x minus 2. So it means we are actually deducting 2 from the y coordinates. So this 0 will be here, minus 2. Okay, then 2 will be at 0. 4 will be at 2. So similarly, each and every single point will shift 2 units vertically downward. So if I join them up, I will get the curve for f of x minus 2. So as you can see, when you are actually using f of x minus 2, it's just a vertical transformation, right? The curve will move 2 units vertically downward. And when you are adding something, the curve will shift vertically upward. In this case, it's a shifting of 2 units. So in this example, this is actually transforming the y coordinates. Okay, so that's why there is a shift of the position of this curve in a vertical direction. For positive, it's upward. For negative, it's downward. Next, we will see if we change the x coordinates, what happens then, and how do we actually know that whether it's we are changing x coordinate or we are changing the y coordinate. And it depends on the position of the of the value. For example, in this one, f of x plus 2, it means y plus 2. F of x itself is the y, right? So y plus 2. But just look at this 2 thing. This is actually f of x plus 2. It was the original one, but now we are actually working for f of x plus 2. So the 2 is inside the bracket. Right now the 2 is inside the bracket. So instead of f of x, we need to sketch f of x plus 2. So it means you are directly changing the x coordinates, not the y coordinates. For y coordinates, it would have been f of x, then a plus 2 beside f of x. So y plus 2. But if the plus 2 is inside this bracket, it means you are actually changing the x coordinates. So that's it. First of all, you need to identify whether it's a transformation of x coordinates or y coordinates. If it's related to y coordinates, then these are the rules. Next, I will discuss what happens with the x coordinates. So this is the original curve. Suppose f of x, it's a quadratic graph. It is at 0, 0. So 0, 0. It is at this origin. It is intersecting with the origin. So the point is at 0. So now we need to sketch, suppose f of x plus 2. It means it is actually changing the x coordinates. So any changes related to x coordinate have an opposite effect. Suppose if you are adding if you're adding 2, the graph won't shift rightward. Instead of that, the graph will shift leftward. Okay, so if you are adding, the graph will shift leftward. If you are deducting, the graph will shift rightward. That's because whatever you do with the x coordinate, suppose x equals to suppose 10. But if you change the x coordinate, suppose if you're adding plus 2 here, okay, instead of x, if you replace it with x plus 2, eventually the final value will decrease, right? When you subtract x from this equation, the final value will decrease. So it means instead of 10, the new coordinate will be 8. So that's why whatever you do with the x coordinates, it will have an opposite effect. If you add plus 2, it means the graph will shift 2 unit leftward. So this 0 will be at minus 2. Okay, so, and each and every single point. This point will be somewhere over here. This point will be here. All the coordinates are shifted leftward. Then if I start this one, x minus 2, so the graph will move rightward, 2 unit rightward. So 0, 0 will be here at 2. This point will be somewhere over here. This point will be here. This one at this location. So the entire curve will be shifted 2 unit rightward. So this is f of x minus 2. And that's f of x plus 2. So I have sketched them on the same axis to show you the relative position between these curves, as in there is a shift in the position, right? So it's visible from this curve. And this kind of transformation where there is a change of position, are called translation. And it happens if you add something or deduct something. It's related to adding or subtracting. So there is a different kind of another type of transformation. There is another type of transformation which is stretch. In that case, you multiply or divide something. Okay, so we will see that next. We are done with the translation part. The first diagram shows translation of the y coordinates, where you added or deducted something from the all the y coordinates. So there is a shift in the vertical direction, either upward or downward. For positive, it's upward. For negative, it's downward. But for the second diagram, it shows the transformation of the x coordinates, and either it's right side or left side. So for adding something, it will shift. Adding something with the x coordinate will shift the curve in the left side, and vice versa. So we are done with translation. we have covered this portion, which is actually translation. You are adding something with the y or deducting or something related to x. Now we will go to this section where you are actually multiplying something with the y coordinates or the x coordinates. So this was actually plus or minus, but now it's into a division. So this is the quadratic equation, y equals to f of x, that's the original curve, and we need to sketch 2f of x. So f of x basically y, so we are actually multiplying with the y coordinates, so all the y coordinates are doubled. So the point which was at 2 will be at 4, the point which was at 4 will be at 8. But this point which was originally at 0 will still remain at 0 because 0 into 2 is actually 0. So that's why the graph won't be like this. There won't be a shift in the position. It will be a change of the shape like this one. The graph will be a steeper one because even though all the points are moving upward, this 0 is still here, right? So that's why you cannot shift this point in an upward direction. So this has to be like this. So it shows that the new curve is a steeper one, right? So there is a change in the steepness of the curve. So that's f of 2f of x. Then half into y. So all the y coordinates will be halved, right? So this one which was at 4 will be at half. Will be at 2. The one which was at 8 will be at 4. So the coordinates will be at a lower level, but the 0 will still be at 0 because 0 into half is 0. So that's why this is the curve, which is a flatter one, right? So in this case, the green one is a flatter one and the red one is a steeper one. So this is a half of f of x. So this is actually changing the y coordinates. Next we will see what happens when you actually change the x coordinates. So for x coordinates, it's the opposite, has an opposite effect. So you are actually multiplying 2 with the x coordinate, but eventually the x coordinates will be halved. Okay, and then again this one, suppose if it's f of x, 2 into f of x, it means 2 into y, but as you can see the 2 is inside this bracket, so that's why it's actually changing. Suppose f of x, but now it's f of 2x, so you just changed the x coordinates. So half x. So the original curve, this is at x-axis y0 will give us 2 points at 4 and at -4. So when you are actually using this one, all the x coordinates will be halved. So 4 divided by 2 will give us 2. So this 4 will be here, -4 will be at -2. But this point, which is something, suppose 0 minus 16, will still be here because the x coordinate is 0, so you are multiplying half with the x coordinate, so it will still be at this location. So that's f of 2x. For the next one, f of half x, it's actually you need to multiply with the x coordinates. So 4 will be at a point 8, -4 will be at -8, but 0. The x coordinate is 0 here, it will be at this location. So these two examples are related to stretch. So for stretch, you are actually either multiplying or actually you are dividing by a scale factor. So these are the scale factors. So basically stretch is related to multiplication or division, and you need to remember that whatever you do with the x coordinates, it's always have an opposite effect. Suppose this is a quadratic equation where the cutting points are at 0 and 4, and you need to sketch this minus f of x. So basically it's more like you are multiplying minus 1 with the y coordinate, but I would prefer solving it by using this shortcut, which is just a reflection about x-axis. You can even solve this entire thing using the method of stretch, as in you are multiplying minus 1 with the y coordinate and all, but this is much easier if you use this concept that it's basically a reflection about x-axis. Suppose if you have a point of 5, and since we are working with minus f of x, you are actually changing the sign of the y coordinates, right? So the positive one, the point which was at a positive part, is now converted into a negative 1. The value is same, the value is still 5, but it's just 5 instead of, it's just minus 5 instead of 5. So as you can see, this point is just reflected about x-axis. So that's easy to actually transfer this curve. So this part here, if I reflect this thing about the x-axis, if I reflect about the x-axis, this portion, when you reflect about x-axis, should look like this. Okay, so then you just shift this part here. So it's just that initially it's a happy face curve and now it's a sad face curve. That's it. So reflection about x-axis. And you can even cross check that the signs of the points have changed. For example, suppose this was at minus 2. Suppose now it's at plus 2. Suppose this one at 10. Now it's at minus 10. So it's just the change in the sign which actually reflects the entire curve about the x-axis. But this 2 point will be unchanged because 0. So at this 2 point, y coordinates are 0, right? At x-axis, y 0. So even if you use minus, it's still here, right? So this intersecting point with the x-axis are unchanged. Next, suppose if we have f of minus x. So you are actually multiplying minus 1 with the x coordinates, right? So this is basically a reflection about y-axis. Because suppose you have something like this. Suppose if you have a point of 2. So when you are actually using minus x, so it's minus 2, right? So this point is shifted here at the left side of the y-axis, so it's basically a reflection about the y-axis. So if this is my curve, points are actually at 0 and 4. I need to reflect this whole thing about y-axis. So this is the y-axis, this is the mirror line. You need to reflect about this y-axis. So if I start with this part, when you reflect about y-axis, this is how it should look like, and then you just continue with the remaining part of the curve. So the point at origin will still be here, but this 4 will be here, minus 4. So this is actually f of minus x, and that's minus f of x.